Humanity's relentless demand for fresh, healthy food is pushing the boundaries of traditional agriculture. Vast fields once yielded seasonal bounty, but our growing population requires consistency, quality, and quantity, regardless of the calendar. This pressure has driven innovation, turning our gaze away from sprawling landscapes and towards controlled environments, where the delicate balance of nature can be meticulously engineered for unparalleled production. The quest for year-round freshness has sparked a silent revolution, hidden beneath vast glass structures. Imagine a farm where sunlight is optimized, water is recycled, and every nutrient is precisely delivered. A place where harsh winters and scorching summers lose their power, and crops thrive in perpetual spring. This isn't a futuristic dream, but the reality unfolding in advanced greenhouses around the world. These isolated ecosystems shield vulnerable plants from extreme weather and seasonal penalties, ensuring a stable environment that promises consistent output. It's a radical departure from conventional farming, where the whims of nature often dictated success or failure. At the forefront of this agricultural transformation is a nation renowned for its innovation, the Netherlands. Despite its modest size, it has become a global leader in sustainable agriculture and the second-largest exporter of agricultural goods worldwide. The Dutch prowess in advanced greenhouse technologies and automated systems for crops like tomatoes is legendary, setting a benchmark for efficiency and environmental stewardship. Their dedication to refining every aspect of cultivation has allowed them to achieve astonishing yields, exporting produce globally. Take Douwesvesten tomatoes, a shining example from the Netherlands. This pioneering farm has mastered the art of high-yield production, demonstrating the true potential of automated systems. Their commitment to sustainability is evident in their use of geothermal energy to heat greenhouses and hydroponic systems that dramatically reduce water consumption. The results are nothing short of astounding, establishing a new standard for what a single, advanced greenhouse operation can achieve in terms of sheer volume and efficiency. The secret behind such monumental success isn't just glass and water, it's intelligence. At the heart of a fully automated greenhouse lies a sophisticated climate control system, the brain that manages every environmental variable. These systems, like those developed by Climate Control Systems Incorporated, have been deployed for over 25 years across North America, Europe, and Asia. They ensure crops grow under precisely stable conditions, adjusting temperature, humidity, and light to optimize growth around the clock, guaranteeing consistent output. From light intensity to CO2 levels, every parameter is monitored and adjusted with incredible precision. This pioneering climate control solution creates an ideal microclimate, shielding plants from external fluctuations. The ability to isolate crops from seasonal penalties and extreme weather ensures a consistent environment, critical for year-round productivity. Such systems are not just about growth, they're about maximizing efficiency and increasing the overall bottom line for growers worldwide, proving their economic and agricultural value. Beyond just controlling the environment, modern automated greenhouses are also engineered for sustainability, particularly in energy consumption. Gel, a tomato grower, demonstrated how strategic use of double screens in a non-lighted tomato greenhouse could significantly save energy. This real-world test provided valuable learning, showcasing how smart design and material choices can lead to more energy-efficient growing power, reducing operational costs while maintaining optimal growing conditions for plants throughout the year. One of the most significant shifts in modern greenhouse farming is the widespread adoption of hydroponics, growing plants without soil. This method offers numerous advantages, primarily in water conservation. Plants receive nutrients dissolved in water, directly to their roots, minimizing waste. Douwesvesten tomatoes, for example, utilizes hydroponic systems, contributing to the Netherlands' leadership in sustainable agriculture and helping them manage water resources more efficiently than traditional soil-based farming methods. The integration of artificial intelligence takes hydroponics to the next level. Research-driven approaches, like those by the Automatos, use autonomous systems to continuously monitor and optimize growth conditions. AI algorithms analyze vast amounts of data, from nutrient uptake to light exposure, to make real-time adjustments, ensuring plants reach their full genetic potential. This seamless integration of technology and research streamlines operations, boosts crop production, and allows for unprecedented levels of control and efficiency. In some advanced Canadian greenhouses, automation has reached an extraordinary level, completely hands-free cultivation. From the moment seeds are sown until harvest, no human touch is required on the crops. The only human contact occurs when the greens are finally packed into boxes, ready for distribution. This level of autonomy, extending beyond just climate or irrigation, sets these facilities apart, representing a paradigm shift towards truly independent, self-managing agricultural ecosystems, minimizing contamination and labor costs. This vision of a hands-free future is made possible by a new generation of agricultural robots, each designed for specialized tasks. One such innovation is the autonomous tomato deleafer. This robot performs the meticulous and repetitive task of removing lower leaves from tomato plants, improving airflow and redirecting energy towards fruit production. The precision and tireless nature of these machines significantly enhance plant health and overall yield, allowing human workers to focus on more complex, supervisory roles within the greenhouse. The impact of these autonomous deleafers has been profound, particularly in Europe. By 2024, 30 units had been deployed across 5 major French tomato cooperatives alone, revolutionizing their operations. This remarkable adoption rate means that these robots now service 70% of the domestic greenhouse tomato market in France, a scaling milestone that underscores the efficiency and economic benefits they bring. The success of this technology highlights a growing trend towards widespread robotic integration in commercial agriculture. While robots can deleaf with precision, the ultimate challenge in greenhouse automation has always been harvesting. Tomatoes, unlike uniform items, vary in ripeness, size, and position, requiring a delicate touch and discerning eye. Developing greenhouse robots capable of accurately identifying and gently picking ripe tomatoes is essential for achieving total greenhouse automation. This complex task has driven significant innovation, creating a foundation for future advancements in agricultural robotics, pushing the boundaries of what machines can achieve. Stepping up to this challenge is Eternal.ag, a Cologne-based agtech startup that recently exited stealth mode with an €8 million funding round. Their first commercial product, Harvester, is a fully autonomous harvesting robot specifically designed for tomato greenhouses. This groundbreaking technology promises to alleviate labor shortages and improve production consistency, marking a pivotal moment in the journey towards completely hands-free greenhouse operations and setting a new standard for efficiency. Eternal.ag isn't just building robots, they're redefining how agricultural technology is developed. Their approach leverages AI-driven harvesting robots, combined with simulation-based development. This allows for rapid iteration and testing in virtual environments before physical deployment, ensuring optimal performance and adaptability. Furthermore, they've introduced a new robot-ready trolley platform, designed to help growers seamlessly transition towards greater automation by integrating new robotic systems with ease, minimizing disruption. The ambitions of companies like Eternal.ag extend beyond just tomatoes. With their initial success and substantial funding, they plan to extend their technology's capabilities to new crop types. This expansion signifies a broader vision for automated agriculture, where the lessons learned from tomato cultivation can be applied to a wider variety of fruits and vegetables, further solidifying the role of robotics in diverse greenhouse environments and pushing the boundaries of what's possible in automated farming. The concept of a robot-ready greenhouse is pivotal. It means designing facilities and cultivation methods from the ground up to accommodate autonomous machines. This forward-thinking approach simplifies the integration of new technologies, minimizing disruption and maximizing the efficiency gains from automation. Such infrastructure is key to accelerating the vision for fully automated greenhouse operations, creating environments where robots and plants coexist in a highly productive symbiosis, driving the industry forward. Building these advanced, automated ecosystems requires significant investment. For example, Bayer CropScience constructed a 300,000 square foot automated greenhouse in Moroniki, Arizona, specifically for corn genetics research, costing an impressive $100 million. This demonstrates the scale of capital expenditure involved in pushing the boundaries of agricultural science and automation, highlighting the long-term commitment required to reap the benefits of these sophisticated farming systems and drive innovation. Another significant investment in cutting-edge greenhouse technology is the Howlings UltraClima greenhouse. Collaborating with the Dutch company Kubo, this project represented a $53.25 million development and construction. The UltraClima concept focuses on extreme climate control, reducing energy consumption and optimizing growing conditions, further illustrating the global push towards sophisticated, high-tech horticultural solutions that redefine efficiency and productivity in agriculture, pushing boundaries of what's possible. The ambition for massive, automated greenhouse complexes isn't limited to Western nations. In the Russian Federation, Ecoculture, the largest producer of indoor vegetables, is breaking ground on a super-modern greenhouse complex. With about 300 hectares of greenhouses already in operation, Ecoculture aims to significantly reduce Russia's reliance on imported tomatoes, currently standing at 500,000 tons a year, by automating as much as possible to ease the burden on human labor, ensuring food security. Ecoculture's operations extend beyond just growing. They encompass robust logistics and distribution centers capable of handling an astonishing 250,000 tons of vegetables a year. This integrated approach ensures that the vast output from their 300 hectares of greenhouses, which includes tomatoes, cucumbers, and lettuce, can efficiently reach consumers. The sheer scale of their operation highlights the complex infrastructure required to support modern, high-volume automated agriculture, from farm to table. Interestingly, despite Ecoculture's drive for automation, they have explicitly stated they will not use robots for picking tomatoes in their new complex. Their reasoning? The region needs jobs. This nuanced approach demonstrates that automation can be strategically applied, focusing on areas like climate control and irrigation to make work easier, while intentionally preserving roles where human labor is preferred or necessary for socioeconomic reasons, balancing efficiency with community needs. The primary objective of all these advanced systems is to decouple food production from the constraints of seasons. Greenhouses effectively isolate crops from seasonal penalties and extreme weather, providing stable conditions for growth. This enables consistent output throughout the year, meaning consumers across continents can enjoy fresh foods like cucumbers, tomatoes, and melons, even in the depths of winter. The predictability of supply is a game changer for food security and availability, ensuring consistent access. The strategic location of these automated greenhouses also plays a crucial role in distribution. For instance, tomatoes grown at Nature Fresh's Delta greenhouse in North America can reach over 55 million consumers within a mere 5-hour trucking radius. This logistical advantage, combined with year-round production, ensures that high-quality, fresh produce is not only grown efficiently but also delivered swiftly to large population centers, reducing transport times and environmental impact, fostering local economies. So, how does this automation translate into actual output? Consider a tomato greenhouse with approximately 200,000 tomato plants. With pioneering climate control solutions and advanced cultivation, such a facility can achieve an annual yield of 4.5 million kilos of various tomato types, including beef tomatoes. This staggering production capacity highlights the efficiency gains from optimized conditions, demonstrating how targeted investment in technology can exponentially multiply agricultural output and ensure food supply. When we look at the combined impact of all these advancements, hydroponics, AI-driven climate control, and autonomous robotics, the ability for a single, fully automated greenhouse to produce 10 million tomatoes a year becomes not just achievable, but a modest benchmark. While some operations, like Duijvestin tomatoes, far exceed this with 100 million annually, the 10 million mark signifies a robust, efficient, and technologically advanced production system, transforming agricultural productivity and feeding millions. While tomatoes are a prime example due to their popularity and value, these automated greenhouse principles are not limited to a single crop. Ecoculture, for instance, in addition to tomatoes, also grows cucumbers and lettuce. The standardized turnkey lettuce greenhouses also benefit immensely from hydroponic advantages in controlled environments, proving that this model is highly adaptable for a range of high-value vegetables and even flowers, catering to diverse market demands and maximizing output. As we celebrate the success of automated greenhouses, it's important to differentiate them from another form of controlled environment agriculture: vertical farms. These indoor facilities grow crops in stacked layers, often without natural light. In theory, vertical farms offer enormous benefits, like hyperlocal production. However, the economic realities have proven challenging for many pioneers in this space, raising questions about the most sustainable path forward for indoor cultivation and profitability. AeroFarms, an early pioneer in vertical farming founded in 2004, illustrates these challenges. Despite its innovative approach, the company faced significant financial hurdles. In May 2021, AeroFarms estimated just $4 million in 2021 EBITDA adjusted revenue, alongside $39 million in losses. This stark reality led them to pull out of a proposed SPAC deal, highlighting the immense expense and difficulty in achieving profitability within the vertical farming model, often due to high energy costs for artificial lighting. In contrast, automated greenhouses often leverage natural sunlight, drastically reducing the energy demands associated with artificial lighting prevalent in many vertical farms. While both aim for controlled environments, the inherent design of greenhouses to maximize natural light and thermal regulation often provides a more cost-effective and scalable solution for mass food production. This fundamental difference contributes to their sustained success and viability in the global food supply chain, offering a greener path. Governments worldwide are recognizing the immense potential of automated greenhouses, actively supporting their development through policies aimed at modernization and sustainability. Vietnam's greenhouse sector, for example, is transitioning from traditional to automated systems, focusing on high-value crops. Such initiatives underscore a global commitment to embracing advanced agriculture as a solution for food security, economic growth, and environmental responsibility, shaping the future of food production for generations. The pace of innovation in this sector is rapid. Events like the Fruit Logistica 2025 exhibition in Berlin regularly showcase advanced greenhouse technologies. Here, the latest in automation, robotics, adaptive climate systems, and smart cultivation solutions are presented to a global audience. These exhibitions serve as vital platforms for knowledge exchange and business development, driving the continuous evolution of greenhouse horticulture and ensuring a pipeline of future advancements and industry growth. The journey towards fully automated greenhouses is far from over, but the trajectory is clear. With continuous advancements in AI, robotics, and climate control, these facilities will become even more efficient, productive, and sustainable. Greenhouse robots, like the Grow Tomato Harvest robot, are not just tools, they are a foundation for future innovation, paving the way for truly self-sufficient agricultural systems that can learn and adapt, minimizing human intervention and maximizing output for a growing world. The ongoing research in fields like machine learning means that agricultural systems can now literally learn how to learn. This capability allows automated greenhouses to continuously optimize their processes, adapting to new crop varieties, environmental shifts, and market demands with unparalleled agility. It's a self-improving loop that promises even greater efficiencies and resilience in food production, ensuring these advanced farms remain at the cutting edge of sustainability and innovation, constantly refining their methods. As the global population continues to expand, the challenge of feeding billions sustainably becomes ever more pressing. The Netherlands, for instance, recognizes that to feed 10 billion people by 2050 at current efficiency levels would require clearing most of the world's forests. Fully automated greenhouses offer a vital part of the solution, enabling intensive, sustainable food production on smaller footprints, minimizing environmental impact while maximizing yield, providing a crucial answer to this monumental challenge. From the precise climate control of the Dutch pioneers to the autonomous robots of Eternal.ag, the evolution of the automated greenhouse is a testament to human ingenuity. It's a story of transforming agriculture, moving from unpredictable fields to controlled environments that can feed millions with unprecedented efficiency and sustainability. The future of our food supply looks increasingly bright and increasingly green, proving that technological innovation can indeed cultivate abundance and secure our planet's nutritional needs for generations to come.